Alright, so 10.1 and 10.2, the law of sines and cosines. So here is the law of sines. You guys should remember this from previous years. And this works for any triangle if you're given the angle side angle, the angle angle side, and the side side angle. Now the side side angle is a special case because we can end up with two different possibilities if you're given two sides and an angle, and we'll do an example of that in class tomorrow. And then you have the law of cosines, which works for side angle side and side side side. And you can kind of figure this out, which one to use, because one is going to have all of the missing components except for one, while the other one will have a lot of missing components. You'll understand what I mean when we actually do an example. Alright, so this is a three-part ratio, and of course you don't need all three ratios in order to solve this. You basically want to pick the ones that help you to solve it the best. So yeah, you could possibly be doing two different cross multiplications at the same time. Alright, but here's the key. It's understanding these. It's understanding that to use this, you need to have these types of triangles, and to use this, you need to have these types of triangles. Now keep in mind that this can be rearranged, okay? If your unknown is a squared, for example, the only difference is that here you're going to have b squared plus c squared, and here it's going to be 2 bc, and then here it's going to be cosine of angle A. Okay? And the same thing for b. So here you're going to have a squared and c squared, and then in this portion you're going to have 2 times ac, and of course it's going to be cosine of angle A. Okay, so let's get started. We already did this in class today, so I'm just going to put it up. I'm not going to go over it. I'm just going to put it up right here. Alright, the next problem down here, I asked you guys to do numbers 2 and 3. Number 3 is the same thing as number 2, except they give you the information you have to draw out the triangle, but you'll notice that when you draw out the triangle, it ends up being the same. So here's that problem. You can stop it, and this one says solve for all the sides. So first I solved for b using these two ratios, and then I solved for c using these two ratios, and I just took b out. Okay? Alright, moving on. Alright, before we really can do anything, I need to explain what this degree and I don't even know what to call this, but like a latitude symbol. Okay? By definition, there are 60 inches, and this is not even inches, I believe it's centimeters, but I'm not sure, in 1 degree on a map. So because of that, to evaluate what the actual degree of this is, you actually have to compute sine. So when you plug this into your calculator to find the sine of this angle, it's going to be, you know what, to rewrite this, let me just tell you, to rewrite this as a full angle without these two terms, you just do 20 degrees plus 50 over 60, and that will be your angle. So when we do this in a calculator, it's going to be 20. Now I know I have the older calculator, so I have to do things a little bit differently. So I'm going to do 50 divided by 60 first, and then add 20. So it's 20.8 degrees. So B is actually 20.83 degrees. And then C is going to be 10 divided by 60 plus 103. It's 103.17 degree. And then side B is 132 feet. Okay, so now that I have this information, I'm just going to make a random triangle. This is definitely not going to be drawn to scale. But angle, I'm going to try, okay, but angle B is obviously an acute angle. Okay, and then angle C is obviously an obtuse angle. And then I'm going to call this one angle A. So it really doesn't matter how you draw your triangle. So angle B is 20.83 degrees. Angle C, 103.17 degrees. And then your side B, which is directly across, is 132 feet. Now because we're given two angles, obviously we can figure out our third angle, which is 103.17 plus 20.83, and that we subtract that from, I don't even know how to do this on this calculator. We subtract that from 180, so it's going to be 180 minus 103.17 minus 20.83, which is about 56 degrees. So based on this information, to find all of the sides, we have B, we need A, and we need C. So because we have all of our angles, we can use the law of sines, and we have a side. So this is ASA. Okay, we can use the law of sines. So A is unknown over the measure of angle A, which is sine of 103.17. B is known, so it's 132 over sine of 20.83. And C is unknown, but we know the angle is sine of 56. So obviously we have to do this ratio twice. First we're going to use these two to figure out A. Okay, I'm going to do this on a separate sheet just because I'm running out of space. So when you cross multiply, it's going to be A times sine of 20.83 equals 132 times sine of 103.17. Now these are all in degrees, so you have to make sure that your calculator is in degree mode. Now the calculator I'm using is, so it's a little different the way I press things on this calculator. But sine of 20.83 is just 0.355, and then sine of 103.17 is 0.974. Okay, and now we multiply. So 132 times 0.974 equals 128.56 divided by 0.355 equals A is 362.16 feet. Okay. Now, if you look at this triangle, this kind of makes a little bit of sense, and it'll make more sense once you actually figure out C. But obviously, A is the widest angle. So because A is the widest angle, its opposing side is definitely going to be the longest. Okay? Now, 20.83 is the smallest angle, so really your answers should not be any less than 132 feet. So when we find C, C should be approximately double, a little more than double 132. So now to find C, I'm going to use 132 over sine of 20.83, which was 0.355, equals C, and then sine of 56, which is 0.829. Cross multiply, so that's going to be 132 times 0.829 divided by 0.355, okay, and C is 308.25 feet, which again, if 20 degrees is 132 feet, then 56 degrees, which is a little more than double, is going to be a little more than double 132, which makes sense. And it's not bigger than 362. Okay? Alright, moving on to 5. So, C is 82.2, and then they give us two sides. So I'm going to draw my triangle, A, B, C. They give me this angle, which is 82.2 degrees, and they give me A, which is 10.9 kilometers, and they give me C, which is 7.62 kilometers. And we have to find all of the sides. So we need to find A, well, all of the missing stuff. So we really need to find B and angle B and angle C. So because I am given angle, side, side. Alright, remember we don't swear in chemistry, but this is the ambiguous case. And I'll show you why in just a second. So let's try solving this, okay? So basically, we are going to use the law of cosines because this is an SSA, but we have to keep in mind that this is the ambiguous case. Now the reason why it's ambiguous is this. So if I was to actually draw this to scale, okay, 82.2, its corresponding side is about 7.62. So 82.2, let's say, looks about that much. And they told me that this side is connected as 7.62. Now they gave me the other side, which is 10.9 kilometers, but they didn't tell me this angle. Now, based on this information, if this is 7.62 and this is 10.9, obviously this is going to be a bigger angle than 82.2. So that has to be a bigger angle than 82.2. So the question basically becomes, how much bigger? And you can't really tell. You can't really tell if it's going to be a little bit bigger or a lot bigger. Okay, so what does that mean based on my triangle? Is my angle going to be just a little bit bigger, or is it going to be a lot bigger? And I know I just drew this completely wrong, and I'll explain this a little bit better in class with some better pictures, but I don't want this video to go on forever. So you know what, actually let's just leave this for class tomorrow. Okay? Alright, moving on to number 6. So number 6, again, here we have our degrees, but our degrees are in terms of latitude and inches, I want to call them. So we do have to remember that when we're plugging them into sine and cosine. Now here we have angle, side, angle, which means it's another law of sines. So Here we have SRT rather than ABC, but it's fine because this is S, this is my R, and then this is my T. And I don't know my R and my T. I do know this angle. It's just basically add these up and subtract them from 180. But we just need to determine the distance of RS across the deep canyon. So all I need to really figure out is the distance from here to here. So my unknown is going to be T. Okay, so I'm going to plug this in. I'm going to do R sine of angle R equals S sine of angle S equals T sine of angle T. Okay, I definitely need this ratio. And I'm basically going to be using this ratio, and you'll see why in a second. So if I plug in all of my information, I don't know side R. I do know that angle R is sine of 102 plus 20 over 60 equals, I do know side S, which is 582 yards. And technically they don't give you angle S, but I can figure it out. So basically all I need to do is 32 plus 50 over 60 plus 102 plus 50 over 60 plus angle S equals 180. And then when you solve that, you end up with angle S being 44 degrees plus 50 over 60, which is 50 divided by 60 plus 44, 44.83 degrees. I'm just going to plug it in as that. So 44.83 degrees equals, T is my unknown, but that's the most important unknown, over sine of 32 plus 50 over 60. Alright, so because I definitely want T, I know I'm going to be using this ratio, and obviously I'm not going to be using that ratio because I have another unknown here. So I'm going to be using these two right here to solve this. And this becomes 582 over 44.83. The sine of that is 0.705 equals T over 50 divided by 60 plus 32, sine of that is 0.542. You cross multiply and you should end up with T, which is the distance RS, is approximately 448 yards. So 582 times 0.542 divided by 0.705. 448 yards. Alright, like I said, I don't want these videos to go past 20 minutes, so we're going to stop here. I do want you guys to do number 7 on your own. This is still law of sines. And this is the law of cosines, and the reason I know that is because I am given SAS. So if I'm to label this triangle ABC, this is my B and this is my C, and I I need to find the length of the missing side or angle of each triangle. So I need to find angle C, angle B, and side A. Okay? So, for this problem, the way that you started off, first off, we can figure out what angle C is. Okay? So, to figure out what angle C is, we can do basically C squared equals A squared plus B squared minus 2AB cosine of angle C. So C is 1 squared equals A, it's an unknown actually, so we don't want to start with C if you labeled it in this way, plus 4 square root of 2 squared minus 2. Again, A is my unknown, 4 square root of 2 cosine of angle C. So this would actually be a bad place to start because we have two unknowns. Okay, so the best place to start actually is to find A first. So find the third side first. I apologize for that. So we're going to find the third side first. So A squared is equal to B squared plus C squared equal minus, 2, 4 square root of 2 times 1, and then we have cosine of angle 45. So we can do this problem, and when you figure this out, you end up with A, and this is just plug in the calculator. I wouldn't do it all at once because a lot of you guys do forget to put parentheses. So A ends up being 5. Now once you found A is 5, you can figure out one other angle, and you would do what I was trying to do up here, because now I know that A is 5, and my only unknown is angle C. So you would use this and then find B. Alright, we're going to stop here, and we'll pick it up tomorrow in class. Of course, if you want to try these, go ahead.